Now let's have a closer look at some of the adjustments that we can make to the sextant in order to calibrate it. We see that there is an adjustment screw on the back of this index glass, this index mirror. And if I adjust it, if I turn this, you can effectively see that these two clips here are going to act as the hinge and therefore cause this mirror to move forward. And if I turn the screw the other way, then the spring action here will push the mirror back this way. We require that this mirror is a perfect 90 degrees to the frame, which is the plane of the instrument. The frame, or in fact this limb, also known as the arc, is effectively the reference plane of the instrument, and we want this guy to be 90 degrees to that. There are also two further adjustments to this mirror here. You can see that if I adjust this screw here, that this mirror will effectively hinge around here. Think of it like opening a door. I'm grabbing the door handle, and there are the hinges of the door. So this screw here, closest to the frame, would cause this mirror also to move this way and that way. Okay, or let me illustrate it like that. Then finally this adjustment, which will then cause the mirror to hinge around these two clips, will then cause this movement. In fact, that would be the complementary movement to this index mirror's movement. So each of those will perform a function which will allow us to calibrate the instrument. Those are your three main adjustable errors. The first one we'll talk about involving this screw on the index mirror is the adjustment for error of perpendicularity. That is to say, we want this mirror to be perpendicular to the frame of the instrument. So in order to do that, let's do the following. We're going to remove this telescope or blank side tube, which in this instrument you pull opposing like that. I'll leave that piece in. I'm going to set this to around about 35. That's about as it is now. And what we do now is we view the instrument this way. We view the instrument holding it like this. If you look at my finger and look in that mirror on the left there. So look at the reflection of my finger in that mirror. See, just look, I'm moving it here. And in particular, look at that plastic part of the arc there. Now compare that to the view over here of this limb, which you can see directly. No mirror, no nothing. So that direct view there and this reflected view here, they appear to be roughly in line. If I hold the instrument there. Let's put them out of line. Let's turn the screw in the back here. And if I do that, look how out of line they look. Let's move them the other way. Look at how they're out of line. Again, let's be clear on what I'm showing you. I'm saying compare that level here to literally to this here. There seems to be a discontinuity. But if I adjust this screw here, at some point I can adjust it so that they appear to be in line. And there you see, they looks like they're in line. The true and the reflected image here on the left, the reflected image there of this arc versus the true one, they appear to be in line. That is the first adjustment which I'm going to make. That's the adjustment for error of perpendicularity. And if we've got it right, which looks like we have, that will prove that this mirror, this index mirror, is a perfect 90 degrees to the frame. Next, we'll discuss the other two adjustable errors.